So now what you want to do is plot a graph of the frequency. So you're going to calculate that from the periods that you measured here. You're going to plot a frequency against 1 over L. So 1 over where L is the length of the string. Now, if you go back to equation 4, you'll see then that you're going to have a linear equation in frequency versus 1 on L. So you can linearize that equation the same as we did with previous experiments to pull out the information that you need out of the expression. And in this case, you're looking for a value of root t on mu. So if you look at the expression, you can basically pull root t on mu out of the slope of that graph of f equals 1 on L. So if you don't understand how to do that, go back to the tutorial on graphs and you can refresh yourself on that or ask your demonstrator. So the second dependence that we will look at is the dependence of the tension of the string. So we're going to set the other two parameters, the length of the string and the linear density. We're going to set those constant and we're going to change the tension. So first of all, you set the bridges to be 300 millimeters apart, so that's from here to here, and make sure it's kind of centralized over the pickup. Okay, so now you adjust the tension over here to around 50 newtons. Not around 50 newtons, exactly 50 newtons. And you may need to change your time division so you have one wave. Also note that if you pluck the string in a funny way, you get this wiggly kind of thing happening. So you need to sort of pluck the string in a way that it doesn't generate the harmonics. So what you're seeing here, when I do this, is a single harmonic, the fundamental harmonic. When I pluck it in a funny way, I actually generate a bunch of other harmonics. So I actually found it difficult to do it then. Yeah, so you can see all the harmonics there. So just pluck it so you just get the fundamental like that. It takes a bit of practice. So set the tension to 50 newtons over here and take your measurements. So take hold off, take a measurement, and do that 3 times for that tension. Then just adjust it down to 40 newtons and take another 3 or 4 measurements. So do that in increments of 10 newtons until you get down to 20 newtons, and then you should get enough points to plot a graph. So you want to plot a graph of the frequency as a function of root t, so root of the tension. So from that, we should be able to extract the information that you're required to get out of the slope of that graph. So for the next part of the experiment, we're looking at the final dependence on the frequency on the linear density of the string mu. So to do that, we're going to change the diameter of the string. So this is the lengthy part of the experiment because you have to keep taking strings out and changing them. So what you're going to do then is you're going to set the length of the string, you're going to set the tension, and you're going to change the linear density or the diameter of the string. So first of all, you need to characterize all of your strings. So you need to work out what the linear density of each of your strings is. So we're going to do this for 4 strings. So the one that's currently in there is a good start. And in the box here, you have another bunch of strings. So you can choose those. Now what you need to do is use your micrometer then to measure the diameter of all of your strings. Now take 5 or 6 measurements, get an average, and take them at different points on the string, and you'll get an average for the diameter of the string. Now remember that we have an equation 3 in your notes that we've already worked out what the density of our strings is. It's all the same as the length of that small length of string. We can calculate what the linear density of each one of these strings is. So calculate that, put it in a table, and you've got that ready to go. So you have the mass per unit length of all of your strings calculated from the diameter and the density that you calculated before. So, yep, put your string in as before. Separate the bridges by 30 centimeters or 300 millimeters. Adjust the tension to 35 newtons. And pluck the string. And press the hold button and get your signal. So do that 3 times for each string. So when you're finished, you'll take this string out, put the next one in, tension it up exactly the same way as you did that one, and then you have a bunch of points. So what you're going to do then is you're going to plot the average frequency for each one against 1 on root mu, or 1 on root of the linear density. And again, we'll be able to extract the information that we need out of the slope of that graph.